Hello everyone. Today let's solve the problem number 2707. Right. So extra characters in a string. Sorry. So what the question states here? We are given a string S. See here. We are given a string S. Right. And a dictionary of words. See here. And a dictionary of words. It consists of the words leet code as well as the leet code. Right. So we must split S this one. We must split S into the substrings such that substrings appear in the dictionary, right? Substrings appear in the dictionary and minimize the unused characters, means extra characters, right? So we have to minimize the unused or the extra characters basically. So we have to return the minimum number of such extra characters, right? So we have to return the minimum number of such extra characters. See here, output is 1. Why? They have given simple this one explanation here. We can break S into two substrings, right? So we can just break the S into two substrings. Lead from index 0 to 3. See here, 0, 1, 2, 3. Lead. So this one from index 0 to 3. And code from 5 to 8. Quite obviously. Code from 5 to 8, right? So there is only one unused character here. Nothing but S. S is unused here, right? At the index 4. So we will just return the one that we haven't used, right? So just we'll return one basically. So let's come to the example 2. We have say hello world here. In dictionary we have hello and world, right? So output will be quite obviously 3. So we can just remove say here and we can just split this one into two words basically, hello and the world. See here, we can break S into two substrings, hello and from index 3 to index 7 and world from index 8 to index 12. You can just count. This starts from index 8 to 12 basically, world, and hello starts from 3 to 7, right? So the characters at index 0, 1, 2 are not used in any substring and thus are considered as extra characters, and thus they are considered as extra characters, hence we return 3. This is fine, hence we return 3. So this is fine, man. Right. So now I hope this part is completely clear. They have given us wonderful examples just for the sake of understanding, man. Right. So now let's do one thing. Let's discuss the approach followed by the this one complexities, and then let's write the code. Right. So let's consider the same first example. So you can just try to implement the same thing for the second example as well. I'll just consider this first example. Right. So what shall we do? First, let's go with the uh, this one. Let's go with the approach. Uh, first I want to tell you we will be going with the try along with the DP. So for this particular problem, we'll be solving this one try along with the DP, mainly try basically, right? So just remember this one, right? So first, what we will do, let's see. Let's insert all the dictionary words into the try. Let's insert all the dictionary words into the try, right? So this one will be, we are inserting lead, we are inserting code, and we are inserting this one. What do we call lead? What do we say? Lead code basically, right? So this one I would have represented in the form of try itself. So this is fine. So we will be making use of, so this one each consists of the single node lead, right? So this starts from root basically. This is one and this is two. This code, this is one, two, three, and this is one node. And the same thing goes for lead code as well, right? So let me do it quickly. Lead code, right? So this also comes from the root basically. Right, this is fine. I would have chosen different color, man. This is fine. Okay, let me write this in this way. Lead, this is fine. L, this is fine. Then we have code in the dictionary. This is fine. CO, this is fine. This is D, this is E. This is fine. This goes from this one, this one, this one, and also finally lead code. So we will mark the end of the this one try, right? So the last letter basically usually, right? So let me make use of here this one lead code, right? So this is fine. D O D E, this is fine. And try always starts with the root, right? So this one I'll just give root. This is fine. Now we have inserted all the dictionary words into the try successfully, right? So we will be making use of the dynamic programming as I've said. So we will be going with iterated value of the DP, that is nothing but minimum extra characters starting from index I, right? So minimum extra characters, that is starting from the index I. Just remember this one, right? So we will be going with the DP as I've said. So I said that we'll be making use of the try along with the DP for this particular problem, right? Initially. So now we'll be making use of the dynamic programming where iterated value of the DP is nothing but the minimum extra character starting from the index I. Just remember this, right? So next we will start at the index 0 first. We'll start at the index 0 first. We'll try to match the dictionary words in the try. We'll try to match the dictionary words in the try. So first we will this one. What do we call? First we will try to match lead basically, right? So we will jump to index 4 basically, right? So we'll we will jump to index 4. So this one L E E T 0 to 3, right? So this one matches basically, lead matches. So what we will do, we will jump to index 4, this 0 1 2 3. So 0 to 3 we have found lead, so this matches, right? So this is from 0 to 3. Next we will jump to index 4. So at the next we'll jump to index 4. So next we will check any other word in the dictionary matches. So this one matches, code matches actually, code matches basically, right? So code matches, that is from we will jump to this one index 9 basically, right? So this is from 5 to 8 basically, 5 6 7 8 code, right? So this is from 5 to 8 and we will jump to 9. Here in this case we have jumped to 4 and in this case we have jumped to 9 basically, right? So but index 4 S is not in the dictionary, so it counts as one extra character. See here, so we went with code and we went with lit, so S is left here in the middle. So this one index 4, S is at the index 4, which is not in the dictionary, so this is counted as one extra character. So this is counted as one extra character, right? So the result that we will be returning is this one. So we found lead and code, this one 0 to 3, from 0 to 3 and from 5 to 8, and S is not in the dictionary and we are only left with the SC here, this part, and this one is at the index 4. This one is at the index 4. Only one character is present, which is at the index 4, which is not in the dictionary. So we will be returning this value as the output. So the output that we got here is 1, which is equivalent to the output that they have mentioned for the example 1 within the question, right? So our approach works absolutely correct in this case, right? So as we are completely familiar with the approach, let's do one thing. Let's quickly discuss the complexities part and then let's write the code, right? So what will be the time complexity and the space complexity here? So the time complexity would be big O of n into L. So the time complexity would be big O of n into L. We know that n is nothing but the length of S, right? Length of the string S, and L is nothing but the max word length in the dictionary, right? So max length, max word length in the dictionary, right? Since we are going for each index, we will be traversing at most L characters in the try basically. Just remember this one. So overall time complexity would lead to big of n into L. I hope we are clear with the time complexity part. So what will be the space complexity here? Space complexity would be big O of sum of dictionary word length. Sum of, so I'll just write here sum of dictionary word length. So I'll just give here dictionary word length, right? So this is nothing but sum of dictionary word length, right? So sum of dictionary word length plus n, sorry, just give me a second, sum of dictionary word length plus n for the try and DP array, for the try and DP array. So overall space complexity would lead to big of sum of dictionary word length plus n, right? So this will be our time complexity and the space complexity. I hope time complexity and the space complexity part is completely clear, man. The time complexity and the space complexity for the code that we'll be writing in the future would be big of n into L and big of sum of dictionary word length plus lengths plus n, right? So this is fine. So I hope we are clear with the complexities part, man. As we are completely familiar with the complexities part, let's move on with the let's move on, or let's start writing the code. So now let's do one thing. So yeah, let's start with a try node definition first. So I'll just go with static here, class. So this one will be try node. This is fine. So within the class try node, so I'll just go with try node. This is fine. Let me go with the children here. So this one will be new try node. This is also fine. Let me pass 16 here. This is fine. So each node can branch up to this one. Sorry, not 16, but 26 letters, right? So yeah, each node can branch up to 26 lowercase letters. We know this one, right? A to Z. So now let's go with the this one. Boolean value isn't. So again, as I've said, we have to mark in try every time we start with the root, and we will be marking the end of the character or end of the word, right? Or the end character or the end letter, basically, right? So every time, just keep this in mind. So this is try based problem, right? So I'll just go with Boolean isn't. This is fine. Now let me come out of this one entirely. Let's go with the root of the try. We have to start with the root of the try. So as I've said, so I'll just go with private try node here. So this one will be root. Let me assign this one to new try node. So this is fine. So now we will be making use of the insert helper method, man. So we have to insert the word into the try, right? So let's make use of the insert helper method. So I'll just go with not this one. Where did it go actually? Just give me a second. 1 second. Where is our main method actually? Min extract char. Did I delete that one? What did I do? So this one is different one. Just give me a second here. Sorry, I have written this one within this itself. Sorry. This one first we are creating the try node. This is fine. Now this is different actually. Mm, 1 second. Yeah. So this is fine. Now let me go with we have uh went with the root of the try, right? So now let's go with the this one. Let's insert the word into the try. Let's go with the try method, insert method, basically void. So this one will be, I'll just go with insert. This one is fine. I'll just go with the parameter word that we need here. So this is fine. Within the insert method, first we have to start with the root always, right? So I'll just go with try node. Let me assign this one to the root. So this is fine. Next thing is, let's go with a simple for loop here. This one char c word mm, char array, character array. So this is fine. So within the for loop, I'll just go with and index c hyphen a. This is fine. Next, that's character matching. That is fine. Now let's go with a simple if condition here. So if node dot children. So first we are starting with the root, then we are going with this one children, right? So we have to move on with the next node. So this one index, this is equal to null. I have to go with the comparison operator. Sorry, if it is equivalent to the null value, so I'll just go with, let me assign children of index. So let me assign this one to the let's create the instance of try. So if it is not present, then we have to create it, right? So I'll just go with the try node. This is fine, simple. Uh, Now we have to move to the next node. Here in this case, node dot children. So this is fine. So let me pass the index within the array. So finally, we are left with only one thing, that is we have to mark the end of the word as true. So I'll just go with node dot is and. So this one, let me mark this one as true. This is fine. We are done with the helper method. What do we call? What is this helper method? Basically insert, right? So next let's move on with the main method, nothing but minimum extra character. So this is the question, right? So basically we are going with the parameter s as well as the dictionary. This is fine. First, let's insert all the dictionary words into the try, as we are making use of the this one try data structure, right? So I'll just go with string. So this one will be word. So let me go with dictionary. But then the individual words we have to consider, right? Let's insert. So for inserting, I have already written the insert helper method, right? So I'll just make use of the insert. Let me pass word here. This is fine. Simple. Now, let's go with the DP array. Nothing but we have discussed this one in the approach. I have stressed this one multiple times. Nothing but iterated value of the DP is nothing but minimum extra characters from I to end. So I have said this one multiple times during the approach as well. So let me go with the DP array here. So let me initialize it first. So this will be new int of n plus 1. This is fine. So next, let's go with the base case. Nothing but at the end of the string, so no extra characters, right? So this will be dp of n equals 1 or 0. This is fine. So the next step would be, let's fill the dp from right to left. When I say let's fill the dp from right to left, I'll just go with for. So here this one will be int I equals n minus 1, I greater than or equal to 0, I minus minus. So this is fine. Within the for loop, what I'll do, let's go with the first case. Nothing but we have to treat the iterated value of the s as the extra character, or we have to treat s of I as extra character. This we know, right? So this is nothing but the first case. Let me go with dp of I equals 1 plus dp of I plus 1. Simple. Right, next what we'll do, let's move on with the second case. So we have to try matching the dictionary words from try, that is starting at I. So that's what we did in the approach as well. So whatever we did in the approach, the same thing we will be articulating in the form of code every time I say this. So make your approach this one, or try to understand the approach correctly, or make the approach concise and clear, in my opinion, for every problem, right? So whenever you are trying to solve any problem, whether it may be lead code problems, whether it may be any problem, if you are giving cp, or if you are just practicing, make sure that your approach is concise and clear. When I say concise, don't make it this one. I'm not speaking of the memory optimization and other stuff. So your approach has to be concise in the sense you should be knowing how to implement the same thing in the form of code, right? So whenever you think this thing approach, just try to think in the form of code and how to articulate that one in the form of this one. You just have to speak in English, right? So mostly you have to speak in that one, you have to articulate in some language. May not be English, in any this thing language, but in the approach you have to say that, but think in the form of code always, right? So after whatever you say, whatever you first you go with the approach, right? So whatever you think, basically whatever we think in the approach, so that's that thing we should be able to articulate in the form of code. Next, that we have to keep in our mind, right? So now let's move on with the further things. So here it will be dp of I, so this is fine, man. Next, let's move on with the case 2 basically, right? So we will try matching the dictionary words from try, that is starting at the I. So I'll just go with try node here. So this one node equals root. This is fine. Let me go with the for loop here. This one will be int j equals I, j less than n, and j plus plus. So this is fine, man. Right, so let me go with index and let me assign this one to the s dot char at. So this one will be j dot char of j hyphen a. This is one hyphen a. I hope this is fine. Now let me go with a simple if condition here. If node dot this one will be, if node dot children, basically sorry, if node dot children of index, so this one equal to null, then let's break. Means if we have no further match, then quite obviously we have to skip, right? So we have to break, basically not skip, we have to break. from there, right? So completely. So next we have to move with the next node, means node. Let's assign this one to the node dot children. So this is fine of index idx. So this is fine, man. Now let me go with the simple if condition. If node dot is end, this is fine. So within this within the if condition, so if the substring matches, then we have to jump ahead and minimize the extra character, right? So extra character that is present in the this one string s. So that's what we need to do. So this one we have already discussed, nothing but iterated value of the dp is math.min of this one iterated value of the dp along with the, so here this one will be dp of j plus 1 usually, right? So this one will be dp of j plus 1 as per the this one code that we have written earlier. So this is fine. So we are done with the coding part almost. So we just have to return the result for whole string, right? So I'll just go with return dp of 0 in this case, right? So this is fine. Yep, now we are done with the coding part. Let me format the code once and let me hit the run button. I hope this works for the, all the test cases, man. Let's see. We have some two errors here. Semicolon expected. Okay. For node. So this one, just give me a second. What is there in the line number 14? So we have written for loop. So in index, this is fine. So this one has to be if, right? So why I have written for loop here? The tilde set I thought. So instead of if I have written for. Now if this is fine. Huh? Error cannot find the symbol n. Where? Line number 24. 24. So I'm just going with string. Just give me a second here. So what I have done here, so we are inserting the word, this is fine. If is equal to new and oh, so yeah, I have not initialized length at all, right? Here, so this one let me give here. So we'll be making use of a length of the s everywhere. So I wanted to say this one, I didn't say. So let me initialize this one to the length of the string basically. So we make use of this one most of the time. So I just wanted to assign this one to the, or initialize this one to the start. This is fine, man. Let me run this one now. So yeah, now you can clearly see the sample test cases are getting passed. So let me hit the submit button. I hope this works for all the test cases, man. Let's see. Yeah, you can clearly see here all the test cases are getting passed. Means the code works absolutely correct in this case, right? So the code works absolutely correct in this case, right? So now we are done with the coding part, right? So we are done with the coding part. I hope the solution part is completely clear along with the approach and the complexities. For now, this is it. Thanks for watching, guys.